Hey everyone, today we are diving into asymptotic notations and how to calculate the time and space complexity. These might sound complex, but I am here to make it simpler. Let's start. So guys, asymptotic notations helps us describe the efficiency of your algorithm as the input size grows. The three most common ones are the big O notation, okay, then your omega notation and the theta notation. Okay, so big O is actually representing the worst case scenario, showing the upper bound of the runtime. Omega will give you the best case scenario, showing the lower bound, and theta will be representing the average case or the exact bound of the runtime. So let's calculate the time complexity with a simple example. Okay, so consider a loop that is running through an array of n elements. Okay, for example, this loop is, I have written for int I, this counter I have created from 0 to the size of your array. Let's say n is the size of your array and I am using this loop here. Okay, and I have written certain code or like some operations are there inside this loop. Okay, so now guys, what will happen, what will be the complexity of this code? So the loop runs n times. Okay, so the time complexity here will be order of n. Okay, so now guys, if you are working with the nested loops means where you are using one loop inside another loop. Okay, so there your complexity will be going to be the quadratic complexity. It will be going to be order of n square. Okay, this is your linear complexity. Other than that, we are having the logarithmic complexities as well. Okay, and one more complexity is there, that is the order of 1. Okay, that means the constant time complexity. What does that mean? That this complexity is not depending on the size of the input or the fluctuations in the size of the inputs. Okay, so what is happening, for example, if you have created an array, okay, and I have initialized it with certain elements here, and now I want to access the first element. That means if I am using the subscript 1, so I would be using it for the second element. Okay, so this, if you want to access it directly, so here I am not using any loop, I am just giving the memory location directly and I am accessing that element. So here the complexity will be the constant time complexity. Okay, so now guys, let's move ahead. This was your time complexity. Let's say now we will be talking about the space complexity. Okay, so guys, in your space complexity, let's say that you have created an array of the size n. Okay, for example, this is my array, integer array, and I have created it of the size n. Okay, so the space complexity here will be order of n. Okay, although guys, we are having the best cases, the worst case and the average cases, but we will be considering more about the worst cases. Okay, so here the order of n would be there because you are using the n units of space. If you add the fixed numbers of variables, okay, like int x, y, okay, if you are like adding those variables in your program, it does not affect the space complexity much. Okay, so it will be remaining as the linear space complexity only. Okay, and in case if you are creating the matrices, so of course the complexity will be multiplied, that will be making it quadratic. Okay, so this was about the space complexity as well. So guys, these are the generic cases, okay, where we have seen the linear, quadratic and your constant time complexities. But again, if you are talking about only the variables, okay, where it won't be dependent on the size of your input, okay, in that case the space complexity would also be order of 1. Okay, we are having the n number of complexities, like your logarithmic complexities are there, your factorial of the complexities will be there, exponential complexities are there. That we will be understanding when we will be going with each and every algorithm. I will be showing you how to create those algorithms, and while like creating those algorithms, we will be understanding and calculating those complexities along with that. Okay, so understanding the notation helps you analyze and optimize your code. By calculating the time and space complexity, you can write more efficient algorithms, which is very much crucial in the competitive programming and the real world application. So guys, thank you for watching.